Chapter 3, Section 4. We are going to continue this idea of finding zeros. We'll lean quite heavily on software and on technology. So either your graphing calculator or the Desmos app here on these iPads. And remember, if you have graphing calculators, bring it. If you have a laptop that can access the internet here, bring it so that you have the tools you need. And again, we have these laptops that doesn't quite cover everybody in class, so we need a few of the others to bring your own. Fundamental theorem of algebra. If P is a polynomial of degree greater than 1, so in other words, it's or equal to 1, it's a first, second, third, fourth, fifth degree polynomial. And it has complex coefficients. So we can include imaginary coefficients on this one besides the real numbers. Then it says it will have at least one complex zero. There will be a zero out there somewhere. So we get to go hunting for it, and we know it will be found if we are just persistent enough. The linear factor theorem says if I have a polynomial that degree is 1 or greater, and the lead coefficient is not 0, so really it just means at degree 1 or greater, then it's going to have exactly n linear factors. N is the degree. So if it is a first degree, I can have one factor. If it's a second degree, there will be two factors, linear factors that I can factor it into. That ending to the example that I did where we got it down to a second degree polynomial and we factored it in the two parentheses, we had two linear factors on that second degree polynomial. That's the linear factor theorem. We know exactly how many factors there will be. The number of zeros of a polynomial function. If I have a polynomial and my degree again is n equals 1 or greater, it's a first, second, third, fourth degree polynomial, there are exactly n complex zeros. So including the imaginary, if it's a third degree, there will be 3 zeros. Now before we said there could be up to 3 real zeros, because they don't all have to be real. So basically what it comes to is we know exactly how many zeros we are trying to find. A fourth degree polynomial, we've got to find 4 of them. A fifth degree, 5 of them. A second degree, 2 of them. We know exactly how many we are going to find. So there's the link to this calculator for online people. Graphing calculators work, as well as the Desmos app. It works real great too. Find all the zeros of each of the following polynomial functions and write each function as a product of its leading coefficient and its linear factors. What we are going to do is use the calculator to help us in our factoring of this. So if I pull up a graph, I'm going to need my book, aren't I, so that I can see that. You look back at example, was it 1? Must have been example 1. Look in your book at example 1, and we are going to see how this is all going to work. They want us to figure out what our zeros are. So I'm going to, I guess I'll go ahead and call it P of x. You can even call it y equals if you want. And we have an x to the 4th. Yeah, an equal sign would be real useful, wouldn't it? Equals x to the 4th. And then I have minus 4x cubed. Wow, that was kind of unique. Let's change that to a 4x cubed. Is that better? Plus 8x squared minus 16x plus 16. Now, as I look at this graph and compare it to my polynomial, I have a fourth degree polynomial. There will be 4 zeros, including the imaginary ones. But as I look here, where does the x-intercept occur on this graph? At positive 2. Can you tell me what is the power or the multiplicity of this? Is it an odd multiplicity or an even multiplicity? Even. Why, James? You're right. Why is it even? Now, it's an even polynomial, but why is this 2 over here an even multiplicity? It's either a second or a fourth. Anybody remember? From the graph, if it crosses the x-axis, it's an odd multiplicity. First, third, if it just intersects, touches it, and doesn't cross, it's an even multiplicity. I know this 2 must occur at least twice from my graph. So now I'm going to use that information, and I still come back and I start doing my synthetic division to find my zeros, but I'm going to start with a 2. I have a 1, a -4, an 8, -16, and a 16. And I'm expecting my 2 to work. 2 times 1 is 2, -2, -4, that's 4, that's 8, that's -8, -16, and it worked, just like I expected. I expect it to work again, because I know it must be at least a multiplicity of at least 2. So I'm going to take this reduced polynomial, 1, -2, 4, -8, and we always take the reduced one to continue on. Bring down to 1, 2 times 1 is 2, there's a 0, 0, 4, 8, aha, it worked again. Now, I started with a 4th degree. The first reduced is a what degree? 3rd degree. So this one is now a 2nd degree. X squared, 0x, plus 4, where does it equal 0? Once I get to a 2nd degree, I don't continue with my synthetic division. I use other methods. Well, a couple of ways. One way is to try to factor. Another way, since there's just one x term, is to isolate that term. X squared equals -4. How would I get x instead of that x squared? Plus or minus square root. Plus or minus the square root of the -4. Well, what is the square root of a negative? A negative is going to give me an imaginary, and the square root of 4 is 2. I have plus or minus 2i. There are my 2 other roots. They happen to be imaginary to go with these 2 roots. So if I listed all the roots of this, it's 2 with a multiplicity of 2. It occurs twice, a positive and a negative 2i. So I don't really have to list 2 times, but it happens to occur twice. So here are all the zeros of this polynomial. There are 4 of them, including the 2 with a multiplicity of 2. We have to remember we count its multiplicity when we are saying that there are going to be 4 of them. So if I look at this next one over here, I'm going to make a list of my possible values that are going to work. At least I'm going to start with a list of the possible values. The factors of 78, well, 1 goes into 78, 2 goes into 78, 3 goes into 78. So let's see if we can start with this. Over, not only do I have over 1, but I also have over 2. So I can have not only the 1, the 2, and the 3, but a 1/2 and a 3/2, etc., going on like that. And again, if I start out by using a graph to help me isolate possibilities. So let's see if I can make this one a little faster by just changing my numbers. 2x to the 4th, I have just a plus x cubed plus 39, x squared plus 136, x minus 78. And I look at this one, I appear to have they're both odd, a 1/2 and a -3. Looks like the ones that I should start with. So we are going to start with a 1/2 and a -3. I'm going to start with my -3, my integer, see how it plays out. So I have a 2, a 1, 39, 136, -78, 2, there's -6, there's a -5, so that'd be 15. Oh, what is that up to? 54? -3 times 54, help me out. 12, 3, 15. How much? So what do I have there? 3, 6, -26, and that is a positive 78, right? And there is a 0. So my -3 did work. Do you remember the second number? 1/2. I'm going to do the 1/2. we can have fractions that we do synthetic division with. I'm going to do the reduced one. 2, -5, 54, -26. Bring down my 2. Half of 2 is 1. There's -4. Half of -4 is -2. We have 52. Half of 52, 26. There is another 0. It worked out. Now I started with a 4th degree. This is a 3rd degree. Then there's a 2nd degree. And as soon as I get to my 2nd degree, I'm not going to continue with my synthetic division. I'm going to use other techniques. I could try to factor this. May not factor too well. So I could go to the what? Quadratic formula. Forgot my x. I'm going to take negative of b, 4, plus or minus the square root of my b squared, so -4 squared minus 4 times a times c, all divided by 2 times a, and we'll see if we can simplify this. 4 plus or minus the square root, that would be 16. That would be minus 8 times 52. What is that? 416? All over 4. 16 minus 416 is what? -400. All divided by 4. I'm going to put both of them with the 4 underneath. 4 over 4 is 1. Plus or minus, what's the biggest perfect square that goes into 400? Or maybe we can take the square root of 400. What is the square root of 400? 20. So I have, since it's a negative, I have 20i over 4. Well, what's 20 divided by 4? 5. 1 plus or minus 5i. There are 2 more zeros to go with these 2 zeros. So my complete list includes a -3, a 1/2, and a 1 plus or minus 5i. How many zeros are there down here? 4. It was a 4th degree polynomial. Conjugate pair theorem says if you have a complex zero, a plus bi, you always will have its conjugate, a minus bi. Anytime you have a complex zero, it will have its conjugate pair with it. Look back over here. If there's a positive 2i, there's a negative 2i. If there is a 1 plus 5i, there is a 1 minus 5i. It always will be true. So using that idea, they say find all zeros of this polynomial, and they tell us 1 0 is 2 plus I. Well, if I know a 0, and by the way, these complex ones don't show up on our real graph. We can't see those. They're not x-intercepts. So I'm going to do synthetic division. Well, thank you, Jake. Somebody's speakers are working very well over there. I am going to take that 2 plus I and do synthetic division with it because it's supposed to be a 0. 1, -4. I need to spread these out a little more. -4, 14, -36, and 45. So how does it work with a complex number? Well, process is the same. Bring down your 1. Multiply by 1. 1 times 2 plus I is 2 plus I. Now I can only add together the real parts. -4 plus 2, that's -2 plus I. Now I need to multiply these together. Well, off to the side, let me write what I'm multiplying together. I have 2 plus I, -2 plus I. This will take a little bit of time in order to do this. First terms, I get -4. Outside is 2i. Inside is -2i. They're gone. Last terms, plus I squared. What's I squared? Careful. -1. -4 minus 1 is -5. When I multiply these things together, I got a -5. I can add those two. That would be a 9. Multiply by 9, it would be 18 plus 9i. I have to distribute my 9 there. -36, positive 18, -18 plus 9i. Well, I need to multiply these together. So let me do that over here. 2 plus I times -18 plus 9i. First terms would be -36. Outside are 18i. Inside -18i. They cancel out. The last term's plus 9i squared. What's I squared again? Negative 1. So I really have negative 36 minus 9, which is what? Negative 45. Hey, look at that. I certainly did get a 0 when I multiplied those together. Now, since 2 plus I is a 0, I just learned that 2 minus I has to be a 0. So I'm going to use that reduced polynomial, this one right here, and I'm going to do synthetic division again, and I should get a 0. And this keeps whittling down from a 4th degree to a 3rd degree, and I should have a 2nd degree. Then I can use some other methods of solving. So bring down my 1, multiplying by 1 is a 2 minus I. Hey, 2's cancel, I's cancel, I get 0. Times 0 is 0, multiplied by 9. 9 times 2, 18. 9 times negative I, negative 9i. What do you get when you add those together? 0. Sure enough, it worked. That one also is a 0. And this is 1x squared, no x's, plus 9 equals 0. X squared equals negative 9. X equals plus or minus the square root of negative 9, which is plus or minus 3i. There comes my last 2 zeros. So I could make my list. All my zeros, 2 plus I, 2 minus I, or 2 plus or minus I, plus or minus 3i. All my zeros out of it. So knowing that anytime I have a complex 0, its conjugate must also be there, allows us to figure out all the zeros. Find all the zeros of a, what degree is this one? 5th degree. How many zeros am I going to have? 5 of them. 3 minus 5i. We get practice, and this one will be a little bit more time consuming than the last one. It's a 5th degree, and also it won't quite go to all those integers as fast. 1, negative 10, 65, negative 184, and I might need your calculators to help me out with some multiplication here. 274 minus 204. Whoo, big old long thing. So bring down my 1, multiply by 1, that's easy enough. 3 minus 5i. Now I add here, that would be negative 7 minus 5i. Now I need to do multiplying of these two polynomials together, of my 3 minus 5i, negative 7 minus 5i. 3 minus 5i, negative 7 minus 5i. So first term's negative 21, outside negative 15i, inside plus 35. What's negative 15 plus 35? How much? 20. Plus 20i. Notice I still have that I term. Last terms would be plus 25i squared. What's I squared? Negative 1. So that number's really negative 25. What's negative 21 minus 25 more? Negative 46 plus 20i. So I kept the I term on this one. Negative 46 plus 20i. I can add these together. So what is that? 19? 19 plus 20i. We don't want to make any mistakes on our math along the way. Now I need to multiply these two together. So I have 3 minus 5i times my 19 plus 20i. So first terms, 3 times 19, so what is that? 57? All right. Outside would be 60i. Inside, is that negative 95i? 5 times 19? So 60 minus 95? Negative 35i. Negative 35i. Last terms would be a negative 100i squared. So that's plus 100. What's 57 plus 100? 157 minus 35i. 157 minus 35i. What's negative 184 plus 157? $27. Is that right? Negative 27. Double check. We don't want any mistakes. Negative 27. Make sure that's right. 3 minus 5i times negative 27 minus 35i. So, as with all math, be careful at each step of the way. 3 times negative 27. Is that negative 81? Outside, you guys need to be keeping up with me here with your calculators. 3 times 35. Negative 105i, that right? Negative 105 inside. What's that? 5 times 27. Is that 135? Negative 105 plus 135. 30 plus 30i. Plus 30i. Last terms. Plus, what are we? 105i squared? 5 times 35? Let's make that 175i squared. Thank you. So that's really a minus 175. So what's a negative 81 minus 175? Run through your calculator. We have a negative 81 in the start. Then at the end, we have a negative 175. Negative how much? Negative 256 plus 30i. Negative 256 plus 30i. 274 minus 256. 18 plus 30i. 18 plus 30i. We're down to our last multiplication. 3 minus 5i times, and yay is right, 18 plus 30i. 18 plus 30i. 3 times 18, 54. Outside, 90i. Inside, what's 5 times 18? 90, negative 90. 90i minus 90i, ooh, they're gone. Last term's negative 150i squared. I squared's a negative 1, so we're really adding 150. What's 54 plus 150? 204. And you breathe a sigh of release, or relief, because we get our 0. Woo! Now, this might seem like terrible news, but it's really not. 3 minus 5i, that means 3 plus 5i. This one is much easier. You're going to see how this one turns out to be much easier to do. I use my reduced polynomial. 1, negative 7. By the way, you could put the x's back in. These are complex coefficients. Negative 7 minus 5i x to the third is what it is. 19 plus 20i minus 27 minus 35i. 18 plus 30i. And we're going to bring down the 1, multiply by 1. 3 plus 5i. Notice what happens to the i's. They cancel. Negative 7 plus 3 is 4. Multiply by 4. 4 times 3 is 12. 4 times 5. Negative 4. Woo. I didn't mind negative. Negative 20i. Hey, once again. And if it's done right, this will happen every time. The i's will cancel. 19 and negative 12. Make sure I get that right. I just get a 7 out of this. Multiplied by 7 is 21 plus 35i. The i's cancel. Negative 27, 21, we have negative 6. Negative 6 times 3 is a negative 18. Negative 6 times that 5 minus 30i and 0. This one is much, much easier. There is my second 0, my first 0, my second 0. Now I started out as a 5th degree. Now I'm a 4th. Now I'm a 3rd. I'm not to a 2nd degree yet. I still have to go looking for some other zeros on that. I didn't even do my graph yet, did I? I'm just down to a 3rd degree. Let's look at a graph. The graph would not have helped me with those two complex ones. Why not? Those I ones, why wouldn't my graph have helped me? Cannot see the complex ones on the graph. Now I have to figure out where are we. Here we are. We're in example 3. So I need to take, and I've got a new term. I have an x raised to the 5th. And then a minus 10x to the 4th. plus 65x cubed minus 184 plus 274 minus 204. And as you look at this, well, I can see at least one real. Where is it? 2. So at 2, I know, hey, let's try to go find another 0 at 2. And I use that reduced polynomial here, the 1, the -4, the 7, and the -6. I don't have to string it out so much because I don't have these complex numbers. 2 times 1 is 2, there's -2, there's -4, there's 3, there's 6, there's 0. Sure enough, 2 works as well. X, can you write this polynomial now? X squared minus 2x plus 3. Where does it equal 0? Well, let's see if this one factors. Does it? Oh, that wouldn't work too well. Not going to factor, so what are we going to do? Quadratic. Negative b is 2 plus or minus the square root b squared. By the way, when we looked at that graph, I didn't explore very far, but did you see any x-intercepts? No, we're imaginary. We've got a couple more imaginary to find still. B squared minus 4 times A times C, at least these numbers aren't too big. 2 times A would just be 2. So 2 plus or minus square root, that'd be 4, minus 12, all over 2. I'm going to divide them both by 2. So I get 1 plus or minus, what's 4 minus 12? -8. So I need to take care of that -8. What perfect square goes into it? 4. Square root of 4, square root of 2. There's going to be an I out there. What's the square root of 4? 2. What happens to this 2 over 2? 1 plus or minus square root of 2i. There are my last two. My last two are also imaginary complex numbers. So there are 2 zeros. Here's 3, 4, 5 zeros. 4 of them were complex. Always the complex are conjugates. These were conjugates, plus or minus down there. Solve this polynomial. I am going to actually let you guys go here in just a minute. We're going to look at the graph again, and we are going to see where are my real zeros, and I'm going to start with those real zeros and pull those down until I get to a second degree, and then I will use the quadratic formula. Back over here, I want to take the time to go through this one. A polynomial function of degree 3, it has 1, 2, and -3 as zeros. They want us to figure out what the polynomial is. They have just told us the zeros. Well, if they tell me the zeros, I know the factors. If 1 is a 0, x minus 1 is a factor. X minus 2 is a factor. X plus 3 is a factor. There's the polynomial in factored form. I just need to multiply it together. I'm going to use FOIL on these first two. X squared, outside is -2x, inside -1x, that's -3x. Last terms would be plus 2, and then I still need to multiply by my x plus 3. I'm going to distribute my x, then I'm going to distribute my 3. So if I multiply everything by x, x cubed minus 3x squared plus 2x, multiply everything by 3, plus 3x squared minus 9x plus 6. And then get my like terms together, and I will have my polynomial. X cubed, -3, positive 3x squared, well, they're gone. 2 minus 9, -7x, and plus 6. There's the polynomial that has those 3 zeros to it. Same idea works down here, even when our zeros include some complex values. Says a polynomial is going to be a 4th degree, and it has zeros of 2i and 3 minus 7i. Well, let's start out with the same process as before. My polynomial is going to have a 0 of x minus 2i. Now, if 2i is a 0, its conjugate is a 0. So therefore, I also have x plus 2i as a factor. And now my 3 minus 7i, there's also a 3 plus 7i. Now when I write this, x minus the 0, 3 minus 7i, we'll simplify it. X minus the 0, the whole thing, 3 plus 7i. We'll simplify that. 1, 2, 3, 4 factors to go with my 4th degree polynomial. I'm going to multiply these two and these two together. That order seems to me to be a little easier. First term's x squared. Outside, it'd be 2ix. Inside, negative 2ix. They cancel. Last term's minus 4i squared. We'll come back and take care of that. Now I am first going to multiply, or I'm first going to distribute my negative here on these. X minus 3 plus 7i. That's what this looks like. X minus 3 minus 7i. I'm just distributing the negative. Now when I multiply here, I can't use FOIL. I take the x and I distribute. Take the negative 3 and I distribute. I take the 7i and I distribute. So my next one, distributing the x times all three of these, x squared minus 3x minus 7ix. Then taking my negative 3 and distributing, minus 3x plus 9 plus 21i. Then taking my 7i and distributing, plus 7ix minus 21i, let's see, minus 49i squared. There's my multiplication. I'm just distributing those. Now I'm going to come back through and simplify some things. And one thing I'm going to simplify is this I squared to a negative 1. So that's really plus 4 right there. Now down here I have an x squared. I have a negative 6x. That takes care of this one, takes care of these two. Negative 7ix and positive 7ix cancel out. They are gone. I'm going to go to my i's, 21i minus 21i, they cancel out. They're gone. Now this 9 is a number as well as this. What is that number? Plus 49. My I squared is a negative 1. What's 9 plus 49? 58. I'm down to no imaginary units anymore. Now I still need to multiply together. I need to distribute the x squared and the 4. So if I distribute my x squared, I get x to the 4th minus 6x cubed plus 58x squared. Distribute my 4, plus 4x squared minus 24x plus, what's that, 232? Double check. 4 times 58. Like terms, and then I have my polynomial, x to the 4th minus 6x cubed. 58 and 4x squared would be 62x squared minus 24x plus 232. There is a what degree polynomial? 4th degree polynomial that came from, check, these two zeros and their conjugates. Now you guys can work. We go to 9:35, so you still have 25 minutes of working on that. And what I'm going to do, I'm going to back up here, and I will go ahead and finish up example number 4. So you can start working. I'll work through example 4, first by graphing it to figure out what some of my first zeros are. And there are iPads up here. You want to borrow them for that Desmos graphing app.